What's up, everybody? Welcome to another BSV Library Code Along. I am your host, Manifestable. I'm very excited to be with you today, and we are joined by Mihail Shinkech from Script, who is going over our Python Code Along and our Python SDK for BSV. Mihail, welcome. How are you doing today?
Hello, Brett. Yeah, thanks for having me. Yeah, hope it will be a fun little session. So, hope you learn something new.
Thank you for
Uh,
being here with us. I want to introduce my colleagues Jay Cespedes, Bridget Doran, and Rachel Brady. Thank you so much for being with us. We're going to start things off with just some quick introductions. We'll start by asking Mihail, maybe introduce yourself, tell us a little bit about your background.
okay, sure. Yeah. So, I'm Michael. I'm a software developer at a company named Script. And Script was tasked to implement the Python implementation of the BSV library. So, yeah, maybe what's the purpose even of the Python SDK? The original goal we set is we need some standard way of doing everything, the primitives of BSV, so creating transactions, running them locally, uh, and an SDK for wallets to interact to. And we also had to, one main feature was building in SPV natively. Before we had these libraries, there were some Python libraries for BSV as well, but they had a different API, for example, with the J when compared to the JavaScript libraries at the time, and the whole ecosystem was sort of scrambled. So if you had one guy that learned a JavaScript BSV library, and his knowledge wasn't that easily portable to the Python world, or vice versa. So that's the original intention of doing these SDKs.
Excellent. Thank you very much for that intro. And yeah, I want to introduce our panel of my esteemed colleagues. So we'll start off with Jay Cespedes. Jay, introduce yourself and let us know a little bit about your background.
My name is Jay. I'm a computer science student, about to graduate finally in my last semester. I work for Handcash as the tech support. And yeah, if you guys are familiar with Handcash, I'm sure we've probably spoken before in the past. If you guys have any troubleshooting issues, anything related to Handcash that you're having problems with, please feel free to reach out at support@handcash.io. And yeah, I'm happy to be here. And thanks again, Brett, for inviting me.
Very widely read and knowledgeable about lots of different things in the philosophical side of the world. So we have a great back and forth about that. Also, very well read in the philosophical side of things. And a dear friend of mine, we have Bridget Doran. Bridget, welcome to the show. How are you doing? Give us a little bit about yourself and your background.
Sure. Let's see. I've been in technical fields for a bunch of years, 18, I guess, and have done a lot of different things: database administration, querying, network administration, Active Directory, that type of thing. Have migrated much further down the road into more, I guess, higher level things. But so one thing I hadn't done up until recently was full stack development. So I've recently gotten into that. I'm more on the TypeScript side of things than Python, although I can certainly, run a Jupyter notebook. And so I'm familiar and have, played around with scripting and stuff. But so I guess what I'm here for is my love of Bitcoin SV. And I like to understand all the facets of it. And then so I would say I'm here more on a meta level because I'm not in front of my regular computer, so I don't have my dev environment. I do have VS Code on my machine, so I'm not sure how we're going to go about this, but I just wanted to caveat out there that I am not I don't have all my tools. So.
Perfect. Well, thank you so much for being here. And yeah, everyone that is here today just brings something unique. And one of the unique things about Bridget that I've found over the years of getting to know her is really understanding not just the what, but also the why behind the what. That's really powerful and valuable, especially from the developer standpoint, as it's not just about producing code in a robotic sense, but it's really about understanding the interface between the scaling stages that you'll be going through. So I'm really excited for everything that you've been getting into with your full stack development. I want to lead in with an intro for Rachel Brady, someone who I've long admired in this space. One of the things that I admire so much about you is just your willingness to get your hands dirty, really jump in, and just start building. And your feedback along the way has been really valuable in terms of understanding maybe some potential gaps in documentation that could be smoothened out and really help that the developer that's starting from scratch, that also doesn't want to be stymied by the natural obstacles that exist building, but just wants to get started right away. And uh, without further ado, Rachel, maybe introduce yourself, give us a little bit about your background. Thank you so much for being here.
Thanks. Um, I'm kind of like a hobbyist, but I'm learning from professionals. A lot of them were back end, so that's so I am. I work a lot with Python. Like Brett has said, we had a lot of questions about developing through some of the libraries. So I'm, very excited that there's this new library coming out, and I'll probably be bugging Jay about hand cache again too, because we work with multiple wallets, hand cache mainly, and we're trying to add yours wallet for one of the main projects we have is it's called Gibio, Gibio.io. It's like a podcast site where you can earn Bitcoin. The other site, which is mainly Python, is Molly Match. I mainly know Django, which is like a web framework through Python, and I'm also slowly learning all the front end stuff too, because I need to have do that anyway. But I'm excited for this code along because of this new stuff that's out.
Okay, thank you so much. And yeah, before we jump things off, we're going to turn things over to Mihail and just ask a little bit about, what the process of developing the library was like. But one of the things that maybe I'll start off with a question is that, as I understand it, this Python library is a very low level library. Maybe can you talk us through, is that something that's natural with all Python libraries? Is it specific to this library? And maybe how does that impact or set up the developer experience for what they're looking to not only get out of developing with this library, Michal, but also uh, what their journey can look like?
Yeah, okay, sure. So the maybe I'll start with how it came along, so how the process of developing the library went. So initially the goal was to create a BSV library that only deals with the primitives, and it doesn't force you to use any specific service in the background. Its sole purpose is to create transactions, create scripts for it. It doesn't dictate what this script should be, so you have the full power of manipulating the script and the overall structure of the transaction. So you have basically free range of doing that, which some libraries didn't have. So that maybe covers your observation that the library is more low level. It means it has many bells and whistles that you can tune and get what you need. And we want to cover everyone's needs with a single library that's its API is unified across all languages. So Python, TypeScript, Golang, and maybe some others. Yeah, so also a big plus with the library is it natively covers SPV, and along with that is the extended format. It can handle extended format of transaction. So beef transaction. That's basically a transaction format where also the previous transaction is included, and that's really handy for SPV wallets. Since usually how it works is you either have like old services used to do, they either store all the transactions in a database and query them, and maybe even hit an external service to construct a transaction, and adds overhead. It's not the true SPV way, but with this library, you have everything you need to enable true SPV.
Perfect. Thank you so much. Yeah, do you have a question? Go
I
ahead.
was just going to ask a quick question, something I've been curious about lately. So when you said stores the previous transaction, do you mean the Merkle proof for that transaction? Or
Yes.
okay.
Yeah.
That's super cool, because I think that's one of the things I've been sort of like trying to see how this is all getting architected, and awesome.
Yes.
Great.
Yes, it's a transaction format that includes everything you need to verify that the transaction is valid without putting all the chunks and pieces together from like databases and services. So that's the purpose of the extended format. Yes, and it includes a Merkle proof. Yeah, that's a core part of it.
Yeah, I one time heard it explained for those that are new to the term SPV that you don't need to have the world's emails downloaded just so that you can read and verify your own email. There's just an ability to have a validation of just the single item that you're looking to verify. And when we're talking about Web3 and blockchain, the idea of detaching the concept of verification from the concept of having a complete history of everything from the entire history of the blockchain is really necessary to reach this next stage of scaling. And one of the unique parts about this library is that has been built in from the beginning with the mindset that it is future proof. Yeah. Okay. Maybe, Michal, if you have something to present or prepared, we can go through some examples and get a little bit of context for this library.
Sure. Yeah. I was thinking maybe we could go over basically just the documentation and improvise and try to get a transaction on the testnet, create it with Python, broadcast it, and maybe go from there on. Maybe use a custom script or something like that. Is that okay?
Yes, that sounds really great. Thank you.
Okay. So yeah, how should we start? Maybe do you guys all have like a Python environment on your computers right now, so you'll follow along?
Yes.
Okay. Yeah. Cool. Yeah, maybe I should share my screen now, right? I think,
Sure.
Brett, you need to switch something.
I can move. Yeah, once your screen is active and ready to be shared, I can bring it onto the stage. Let me know when you're ready.
Okay. Oh, I think it's already sharing, so I think I'm ready.
Okay.
I'm not seeing the screen.
Yeah.
Is anybody else seeing it?
Right now, I'm just seeing that the screen that's being shared is our video session. So
let me
you
try
might have
again.
to jump over. Yeah.
Stop,
Okay. We have it coming in just a second. Thanks, Michal.
Okay. So yeah, it's now showing for me, but it's gray. So I think you need to bring it to the foreground, right? Okay.
All right.
Okay. So yeah. So you guys can see it. Is it readable? Just let me know if it's too small or something. Is it sharing?
Yep.
Yes, I see the screen now.
Okay. So is it readable, or should I make the text a bit larger?
It's okay for me.
Yeah.
Okay.
Yeah, it's okay.
Okay. Yeah, so yeah, maybe for a start, you can open the documentation page for the SDK. So you basically search for, you Google BSV Skills Center, and you open the first link. And then on the sidebar, you scroll down to SDKs and open the Python one. And we here.
Beautiful.
Okay. So yeah, but the next thing is, I'm assuming you guys have Python installed on your system. So if you type the Python command, it should bring up like this prompt, and you can maybe 1+1 to make sure it works. Yeah.
Yep.
Okay.
Yep. Mhm.
Okay, great. So if you have Python, then you also probably have the pip command, and you want to install the BSV SDK here. So you do pip install BSV SDK, and I already have mine installed. So I'm sure, yeah, it says it already satisfied, but in your case, it will probably download it and install it. Yeah, let me know if there's any troubles here.
Finito.
Finito. Okay, great. Rachel, Bridget, also?
Yeah, I'm okay. Like I said, I'm not on my regular dev environment, so
Okay.
like I do have Python, but anyway, carry on.
Sure. Okay. Yeah.
I
I'm
got
not sure because I now can't see your beautiful faces, so I'm sort of blind.
Right.
So just let me know by voice. So where are we? Yeah. Well, if you have the BSV SDK, maybe let's open up the Python interpreter. So just type Python and try to write from BSV import private key. And hit enter and see what it does. It shouldn't say anything if it's successful.
Mm. No module. Looks like I might have.
What's the module's name?
This is here. No module named AIO-HTTP.
Oh, yeah. In that case, you're missing a dependency. You just do pip install. You said AIO HTTP, right? Just hit that and it should install it.
Okay.
Yeah.
Uh-oh. Oh, wait, I misspelled something. AIO-HTTP. Okay, 1 second. I need a, there you go. Now let's do it again. Install AIO-HTTP. Now it's working. Okay, now I'm installing it. I just had to get out of the Python environment.
Okay. So if you hit this line again, it should work, right?
Yeah, so now I'm going to go from BSV input private key. Bada bing. Everything's beautiful.
Okay, great. Yeah, so basically we're now using the SDK, but in this case we're using an interactive shell, and the purpose of it is just to create a key pair that we'll use to carry the funds for our demo transaction.
And then Michal,
Okay,
we also got one error that said module not found error, no module name BSV. Does that require the?
Yeah, that's in that case you need to pip install BSV SDK, right? And that needs to successfully, maybe depending on the system, you maybe have to do sudo or something like that. In my case, I have like a local environment here in my folder. So pip install BSV-SDK.
Was that successful, Rachel?
I'm checking now.
Oh, no problem.
Oh, I'm running into this silicon thing again. It's
Say
okay.
that again.
Yeah, it's so the silicon chip on Mac, because I'm like trying to whip up a new environment here because I'm on my laptop and not my regular Mac. But it's just given me some grief about the silicon chip. So I just have to, don't worry,
Oh,
never mind.
yeah. Okay, sure. Yeah, because MacBooks use ARM now, so maybe
Yeah,
it's
exactly. That's exactly it.
okay, sure. Yeah. Yeah, what about others? Is it okay now? Shall we continue?
Yeah, I'm okay. How about everybody else?
Sorry
Yeah,
about
I'm
that.
ready to go.
You can go ahead. I think there's something that I'm in the wrong thing.
Okay, sure. Yeah, let's move ahead then. So if you open this one again and re-import, now you can define like a variable, and let's say we'll define a private key. Let's call it private key X or something like that. It could be anything. And say private key, right? And you hit enter. And this will basically initialize a private key from a random number. So mine will be different than yours. So in that case, don't panic. It's the intended behavior. And then we want to print this private key. So let's do private x dot just with, so WIF, and hit enter. And this is basically your private key in a wallet format. So let's just go ahead and maybe open like a text editor and save it for the future. I'll just leave it in here just so we don't lose it in the course of the code along session. And we also want to print the address of this private key. So what we can do is we just do private x dot address. And because we'll be using testnet, we need to specify the network, because by default it's mainnet. So we do network testnet. I think that should be it. So if we hit enter, yeah, it will give us a testnet address, because in Bitcoin, a testnet has a different format than a mainnet address. So even though it's the same private key, it's written differently. So usually testnet addresses start with M or N, and mainnet addresses start with 1. Oh, yeah, mainnet. Yeah, this one starts with 1, but we'll be using this one. So the testnet address. So let's just go ahead and copy this one here as well. So we have everything that we will need. Yeah, now that we have an address, it will be an empty address. We won't have any funds by default in it. So let's get some testnet Bitcoin. And I'm not sure about you guys, but what I like to use is at Ascrit, we have a faucet, and you can get some for free. So just go to ascript.io and / faucet. Maybe let's go through Google, so it will be easier. So just Google Ascript and go to ascript.io. And here in resources, we have the faucet. Let me know when you found it.
I found it.
Same here.
Cool. Okay, great. Yeah, now just paste the address in here and hit get BSV. And if everything's successful, you'll have a green pop-up here, and just click on here, and it will open the transaction on Watson chain. So we'll have the transaction ID, which we'll need later on. So this is basically the transaction that fonts or newly generated key. Right, so here's the address, right, and it sent us, I think, like 100,000, more or less, BSV. Okay, maybe make it bigger. Did it work?
We're all rich. That was easy.
Yeah, great. Yeah, testnet rich. Yeah, cool. Okay, so yeah, now we have a private key with some fonts that we can use to create our demo transaction. So yeah, we can go ahead and close this interactive prompt. And here I already created like an empty folder for our project. So maybe you can do the same. So basically what you do is you do make directory, at least on my system, BSV demo, for example, but you can name it anything. And I'm already in it. Okay. You can also, of course, use like a regular file manager. I do it file. I don't even think I have one. Oh, I have it. Okay. Yeah. So you can also create like a new folder here. It's the same. And go there in our console. Right. You guys have it?
Yeah, I'm just moving here, change directory.
Yep.
All right, yeah, I'm ready.
Okay, cool. Yeah, just now go ahead and open it up in Visual Studio Code. You can, of course, use like another editor. It doesn't. Oh, why do I have this? Oh, okay. Yeah, you can, of course, use any other editor, but since most developers use this, I'm going to use VS Code. Ready?
Ready.
Cool. Okay, so yeah, here, go ahead and create a new file. Let's call it demo.py. So py. And hopefully you can see it.
We can see it.
Mm-hmm.
Yeah. Okay, so just to test it, everything is okay. Let's maybe print hello world here. Save the file and go back to the console. You can also use this built-in console in VS Code, but I'm not really used to doing that, so I will just switch windows. But you can do it below here, right? So terminal, yeah. You can also do it here, but I'm not used to, so I'm gonna switch. And here, you just do python demo.py, and it should run the file, and it should print hello world.
Finito.
Cool. Okay. Yeah, so now that we have everything ready, we can go ahead and go to the Python page of the documentation of the skill center. And yeah, we already did that. So it shows us how to install the package, the SDK. And here it describes dependencies that we'll need for our demo file. So we're just gonna go ahead and copy this and delete this, and oops, yeah, let me, okay. save it. So what this does, it imports everything that we'll need for this demo script. So from the BSV, it imports things such as private key, a template for a script. So we're going to use pay to public key hash, which is just a regular transaction in Bitcoin. Also the transaction class and the transaction input class and a transaction output class, because each transaction has inputs and outputs. We're also going to need this async IO library. You might have to install it, but I think it should be included by default in most Python environments. And why we need this is because Python by default doesn't support the await syntax. So if you code it in JavaScript, maybe you're familiar with this. And it basically lets us wait for asynchronous methods to finish. Right? Okay, so can we move ahead?
Yes, thank you.
Okay, great. So now, this code shows us how to create a transaction, how to define the private key, get in the source transaction, create a new transaction that unlocks this source transaction, and broadcast it. And it does it all in this short script. So let's just go ahead and copy this, paste it below what we just had here. Okay. And now here in this private key, we're just gonna delete this placeholder that we have in here, and we're gonna go ahead and copy the private key we created in an earlier step in here. So let's go back here and paste it in here. Okay. So that's the private key, not the address. It's the private key. Let me know when you're ready.
Sounds good. I'm ready.
Ask a quick question. It says WIF format.
Yeah.
Is there sometimes private keys that aren't WIF format? And what is WIF format?
Yes. So a WIF format is basically it's an abbreviation of wallet import format. So what it is, you have Bitcoin addresses that are like numbers that you can easily write down, and it doesn't have many similar characters like I and L, and it sort of helps you get the address correct. So wallet import format for private keys is sort of the same. So you could define a private key in pure hexadecimal or even in binary, but this format it's easier to write down, and it also has a checksum built into it. So if, for example, if I put a wrong letter in here like E, it will immediately crash because the checksum won't be correct, and it's more safe that way.
Thank you.
Yep. Yeah, so I think you're ready. So in here, in this next line, we're gonna put in our serialized source transaction. So this transaction will already be on chain, and this will be the transaction that we created using the Escrow faucet before. So if you go back to the browser and you have this open, right? So for the transaction ID is FD, FBD, 90, and so on, but yours is probably different. I mean, it surely is different, but you're gonna need the transaction ID. And we wanna get this transaction in its raw format, so just a large hex string. And there are many ways to get this. What's on Chain doesn't have built in by default. For example, it gives you this JSON structure, but we will need it in raw format. So what I do is I click this API link in here, and this will open up the API documentation of What's on Chain. And in the sidebar, I go to transaction, and on the right-hand side sidebar, I click on this get raw transaction. Oh, yeah, this one, get raw transaction data. And in here we'll have this link. So you can basically get this via the browser. You can also use other tools such as CURL or Postman, but we're just going to use a browser since I assume everyone has a browser open now. So just go ahead and copy this link. And we're going to be switching a few things in here. So yeah, let me maybe go to a text editor since it won't be visible in my bar because it's a little bit bigger. So we'll have this link, right? And in here, we have a placeholder for a network, and we're going to delete this and write test because we're on the testnet network. Let me know when you're ready, so I won't be too far ahead of you.
I'm ready.
I'm ready.
Okay, great. And we have another placeholder called hash, and in here we'll put in our transaction ID that we created using our faucet. So this string right here, you can just click on this copy hash, and it will automatically copy it for you and paste it in here instead of the placeholder. So, let me. I'm not sure why I didn't copy it. Okay, now I have it. So let's put it in here. Okay, so that's the link ready, basically. And just go ahead and copy it, put it back into the browser, hit enter. And in my case, it's a Chrome browser. It just downloads it as a file. It doesn't directly display it. So just just click on this file that you just downloaded. For some reason, mine opens it in Office, but hey, that's fine as well. So this is basically our serialized transaction. That's the whole transaction that we're going to need. And we're going to copy this. Let me know when we can continue.
Done here.
Okay.
I'm good.
Okay, very good. Yeah, just go ahead and copy this. You can close it and put this in here instead of this. I'm gonna paste it in here. So this variable should be the serialized transaction that we just copied.
Finito.
Okay, good. Yeah, so yeah, now maybe let us go over the code here so we even know what's going on. So let me just comment this out. And let us just basically go over line by line. So what it does. So we first have like a string or private key in a string, which has this wallet import format in it, but we need to parse it in to create a private key object. So what we do is we just create a new variable called private key, and we have the private key class, which we're gonna instantiate by putting this string in its constructor, right?
Okay, I see.
Yeah. Okay. Yeah, so moving ahead, we'll also need to do the same with the transaction, which is also just a string as of right now. But what we want to do is, again, turn it into an actual object in Python. And we can use so we first define a variable. So let's call it source transaction. And we're going to use the transaction class. And we have a static method called from hex, so from hexadecimal. And this function takes in a string, which contains this source transaction. So let's just put in here source transaction hex. Okay.
Okay.
Finito.
Okay, great. So now what we have is we have our private key and we have our source transaction ready to be used. And now what we're going to do is we're going to create a new transaction that unlocks the output contained in this source transaction. Does that make sense? So this source transaction is the transaction already on chain, and we're going to have it here locally. And because we want to transfer the funds that are locked into it, we're going to create a new transaction that does this.
Understood.
Right? Yeah.
Mhm.
So first, what we're going to do is we're going to define the inputs of this new transaction. So let's call it transaction inputs. And well, we'll have only one input. So let's just do tx input. And we're going to use the transaction input class. Going to instantiate it. And it takes in a source transaction, which is this here, right? Which we already have. So let's do source transaction equals source tx. And then it also says here that we should also put in the source transaction ID. But since this transaction is actually complete, or the SDK will do this automatically. So we can leave out this line here. And we're just going to move ahead and do source output index. So this is the index of the output in the source transaction that we're going to unlock. And if we take a look at this transaction that we created, it only it only has one output, and that contains our funds that's basically in our wallet, right? And so the index will be 0, because in Python we start indexing from 0. So 0 means first output, right?
First index, right?
Yeah. And here, because this output is a regular payment, and what that means is the script contained in it, that's a pay to public key hash transaction or script. And it sounds more complicated than it is. It's basically a script that pays to an address. So usually any payment that you make with a wallet or anything, it does contain transaction created by this does contain the same script. So that's a P2 PKH. That's the abbreviation. Any questions about that?
Not yet.
No, but just,
Okay.
I mean, this is the obvious question, but you would want to make sure you pay it to an address that you control typically, right? Unless you're wanting to do something where
Yeah.
you would be getting rid of a contents of a transaction. But in this case, yeah, you want to pay it to a address that you have the key to.
Yes, exactly. And in this transaction, we see this chunk here, right? And that's basically the address. So, Brett, you before asked like, what's wallet import format, and can it be like in another form? And here, that's a perfect example of that. Here, it's in hexadecimal. So that's basically this address, right, that we created. So N2, right? Maybe I can make this bigger. This is our address in a wallet import format, and this is the same address just in hexadecimal in the script, right?
Understood. Thank you.
Thanks.
Yeah. Okay, so so now in our new transaction, we want to provide a solution for this script, right? And basically, the script has this object, right? And we want to create a signature for this. But now we could do this manually by creating like a signature using like an elliptic curve library and doing the signature manually. But in the BSV SDK, we have this really high level abstraction, especially for standard scripts such as pay to public key hash. And it's called just a script template, and it's called pay to public key hash. And that's imported from the BSV. And what it is basically it's code that tells our transaction how to unlock the previous transaction, right? How to create the unlocking script, basically. And we're gonna put this in here. So the constructor, and it's called unlocking script template. And the way you do it is you just do pay to public key hash. You create a object from it, and then you call the unlock method on that, and it takes in our private key, because the private key or library needs the private key in order to create a valid signature. So that's what it takes in, right? Does this make sense?
Yes, but may I ask you just a question here? So this is partially because of two things, but one of those is because you're using pay to public key hash. But if you were using a different type of script template that was more custom, then it wouldn't. You could change it so that it doesn't necessarily only need the private key, but maybe it may need some other validation, and that's where you were talking about it having the ability to be customizable. Is that correct?
Yes, exactly. So this is so if you take a look at the class, right, this derives from the script template class. And if you have some custom script, you can do this yourself. You can derive a custom script template. So in here, the SDK defines a few like standard ones. So for example, it could be like op return output, a pay to public key. So that's not the address, you directly pay to public key. You have also a multi-sig template, but you can create a custom one and define custom logic in it, right? But we're just gonna, since a pay to public key hash is pretty standard, we include it as a template that handles these types of scripts automatically for you. So you don't have to write this yourself, right?
Yeah.
And in here, in the script template, you basically define how to create a locking script for this script and how to create the appropriate unlocking script to unlock such a locking script, right? So this is the unlock method that we're basically calling in here, and it takes in a private key. But like you said, Brett, it could be, you could create like a custom template that takes in 2 private keys, and you would do another private key, right? And create a signature from it. So this is also a method that creates a signature for it and constructs the script, right?
Got it.
Yeah. Okay. So yeah, everyone up ahead, so I can continue.
Yeah, I'm ready.
I'm ready.
Okay, great. Yeah, so we have our new transactions input, but we'll also need obviously another output, right? Because each transaction has to have at least an output. So yeah, let's just define this output. So let's write tx output equals transaction output. And this class takes in the locking script. So in here, you could basically create a new locking script or pay any locking condition that you want. But we're gonna do just public key hash again, pay to public key hash. So just a regular payment. And yeah, let's just for the sake of simplicity, so we don't have to create a new private key each time, let's just repay it to our address. So we're essentially paying back to ourselves. But yeah, in here you could pass any address that you would like, but we're just going to use the same address, from our private key.
For convenience, understood.
Yes, yeah, and because because this is the testnet network, we're just gonna use which is gonna pass in here that the address is a testnet address, right? So that's in the address function call.
That's what's that? Testnet. Okay.
Yeah, testnet.
Okay.
Yeah, good. Okay, yeah, and it takes also another parameter. Now we could here in the transaction output, if you take a look at the constructor signature, we could either manually specify the amount of satoshis it contains, so how much we'll pay ourselves basically back, right? So we could write satoshis and write like I don't know, like 10,000 satoshis in here, right? But we can leave this out. Yeah, well, let's not leave this out. Let's actually define it. So let's just quickly take a look at how much our UTXO even contains. So we don't put in more than we have. So it's 99,000. Yeah, so we can pay 10,000, let's say. Okay, let's maybe even put more, like 30,000. 30,000. Okay. Yeah. And well, now, so can anyone tell me if you have an input that unlocks a UTXO with 99,000 satoshis and you pay in the next output 30,000 satoshis, what will happen? Like, and we only have one output. So the difference.
The
Yeah.
difference, would the difference go to the miners unless you send back to yourself?
Yes, exactly. That's exactly right. So, and because we don't want to pay like an exorbitant amount to miners in this case, for example, our difference is like 70,000 more or less, right? We can put in another output, let's say TX output, a change output, like you said, yeah, that pays back yourself, right? And in here, yeah, let's just copy what we have above. It will also pay our address. So in a regular transaction, this would contain the recipient address, right? But in our case, it's just the same. And this will contain your address because you want some change back, right? Because you don't want it all to go to the miners. And in here, instead of writing satoshis, we're putting a change flag and we set it to true. And this means the amount of satoshis in this change output will automatically be calculated. So only the minimum required amount goes to the miner and not more.
Understood.
Yeah. Yeah, let me know when we can go ahead.
Okay.
Yeah, I'm ready as well.
Okay, great. Yeah, so now we have our input and our two outputs of this transaction. Yeah, let's just put it in actual object of a transaction. So let's just define tx equals transaction, and it takes in as an array our inputs. So because we only have one, we just put square brackets and just put tx input in there. And then we're going to do comma and square brackets again. And here will be the outputs. So tx output. So that's the first payment output. And we also want to put in the change output. So tx output change, right? So this array contains the outputs. And yeah, we can also put in the version of the transaction. That's like, I think this should be actually automatically derived, so you don't have to worry about that. So yeah, version, yeah, transaction version, or one, yeah, it should be automatically. So we can leave that out actually.
Okay.
Yeah. right? So now we have our transaction ready locally as a Python object. So what are we trying to do next? Can anyone guess?
One second here. I'm actually bumping into a little problem. I think I might have transaction output change. What did I do wrong here? Transaction output change. For whatever reason, sorry?
I was gonna say, are you looking at line 27 or
30,
are you
33? For whatever reason is not defined. Transaction output change is not defined.
Check if it's the same, if it doesn't contain a typo. It needs to be the same as you defined it here, right?
There it is.
So
I
maybe,
see it. Yeah. Got it. Oops. Okay. Sorry about that. Yeah, everything's good now.
Okay, great. Yeah, so can anyone guess what we need to do next now that we have our transaction ready as an object?
Broadcast it?
Broadcast, yeah.
Yeah, basically, and under the hood we'll serialize it as a hex string basically, and broadcast it to a miner, right? Exactly. So what we're gonna do is, well, first it actually needs to, because we set this change output, right, and it doesn't have the amount is dynamic. We need to call await, and we're gonna call the fee. Well, I don't think it even needs to be awaited. So yeah, we're gonna do this, and what this does, it actually calculates the change, right? So what this function call does is because for now our second output only has a placeholder for the amount, and once we call this, the SDK takes a look at the whole transaction, calculates what the appropriate fee for the miner should be, and it sets it calculates everything so everything is fitting. So this should contain like 70,000 minus the miner fee amount. Right? So
Yes, and then if that is a dynamic amount, maybe it could change from month to month or something. Will the SDK take variable information to determine that?
Well, in this particular case, I think what we have here is we have a fee model. So that's another interface like a script template, for example. And we have the fee model that you can pass in here, a custom fee model maybe. But our default one, so this line, if we didn't pass in a model, it takes a fixed amount. So that's Satoshis per kilobyte and 10, right? So 10 Satoshis per kilobyte. That's the default behavior. But again, because this is just a class that extends the fee model, you can define your custom fee model. And in that case, you could maybe create a custom fee model that queries a particular service and get the actual fee rate that's currently happening. But by default, it'll just use 10 Satoshis per kilobyte.
Okay, understood. Thank you.
Yeah. Okay. Yeah, let me know when we can go ahead.
I'm ready.
Okay.
Ready.
Yeah. So the next line that we'll do is we're going to call the tx sign function, right? And this is sort of like similar to fee, but instead of setting the change amount, will actually set the signature that unlocks the output, right, of our previous transaction, the source transaction. Because until the transaction isn't finished, we can't create this signature. For example, we couldn't define signature in here or something because we don't have the transaction completely built yet. And the signature is a signature of the complete transaction. So that's why we do it on the end, right? And we have a simple way of doing it. It's just tx.sign, and depending on the script template that we'll use, it will automatically create the appropriate signature. So that's when this unlock will actually get called. Right?
Mm-hmm.
So we're signing the transaction. Understood? Any questions?
So far, so good.
No.
Okay. Cool. And yeah, now we're basically done, so we can broadcast. And we'll do, it's an asynchronous method, so we'll await it. And we're going to do await tx.broadcast. And because we're again on testnet, and by default, the SDK assumes that you're using mainnet, we're just gonna use, let's import it. We're gonna use the what's on chain broadcaster. And broadcaster is again a class that you can customize, but we'll have some default ones. We have, for example, we have the orc broadcaster, which will use the public orc API, or we have the what's on chain broadcaster, which will use what's on chain to broadcast the transaction under the hood. And we're going to use the what's on chain broadcaster in this example. But you could also use orc or define a custom one that uses a service that you like. Okay, so we're going to add this to the imports, and below here, we're just going to pass this in here. We're going to initialize this broadcaster in here, and we're going to set the network to test.
So this one says just test instead of testnet.
Oh yeah, that's one. Maybe we could probably improve this, because how the what's on chain broadcaster works, it basically puts this string in here, and that's one thing about what's on chain. They don't say testnet; they only say test. So that's why it says here test. But yeah, that's a good point. That's some good feedback. That maybe we could extend this to automatically translate testnet back to test, and so you'll have like a unified. But in this case, we'll just do test. Okay. Yeah, should be good. Yeah, I think. Yeah, and once we broadcast it, let's just print. Maybe just here print the transaction ID. Let's just copy these 2 lines in here. So this will print the transaction ID and also the raw transaction that's over new transaction, right? Yeah, let me know when you're ready.
Okay, I have
ready.
Yeah, so we can just delete this now since we don't have to need it anymore. So this is basically our script. So maybe let's go ahead and try to run it and hope for the best.
Yeah, fingers crossed.
Yeah, fingers crossed. So let me close this. Yeah, go to the console again and just type Python demo.py.
Don't forget to save.
Don't forget to save, right? And you should get a transaction ID here. And now let's try to copy it if it was actually broadcast. And maybe you just refresh this page here, right? Yeah, and we can see that the output was successfully spent. So you should see this line below here, right? If you refresh the what's on chain page that you had open for the source transaction, you should now see this spend indicator. And if you click on it, you will go to the subsequent transaction that we just created. See it? It's the same ID that was printed in here. And it contains two outputs. Both of them pay ourselves, but as you can see, it paid 30,000 Satoshis as a payment. And then it also created the change output, which is, I think, 69,000 BSV. Yeah.
Beautiful.
And yeah. And this was also done automatically. The fee for the miner was calculated to be 3 Satoshis. So yeah,
Nice.
now we're making some testnet miners testnet rich.
Awesome.
Yeah.
Don't
Okay,
spend it
yeah,
all in
let me
one
know.
place.
Yeah. Yeah, let me know if how it went for you guys.
Yeah, everything is perfect here. I'm on the test block explorer. So miners actually have to expend money. This isn't just like a mock-up mining situation. This is actual miners putting
Yes.
effort into mining these transactions.
Yes, correct. So this is the testnet network, but it's constructed the very same as the mainnet network, and you have testnet nodes that mine this testnet network. But for the testnet, it's a bit simpler because currently I think only Gorilla Pool has testnet nodes. But yeah, anyone can set up a testnet node as well and mine. Yeah, so this is functionally.
Okay.
And the block rewards are fake Satoshis.
Yeah, fake Satoshis essentially. Yeah.
Okay. And just out of curiosity, what's the hash rate on the testnet? Because I'd actually like to just like fool around and maybe like set up a node and mine some transactions on the testnet.
Maybe you could actually succeed since usually it's a lot lower than on the mainnet. So let's see. So it's in here, it says 10 to the power of 21 hashes per second. And let's go to the mainnet page to compare. Where is it? Yeah, let's delete this test prefix. So that's the mainnet page. And yeah, 10 to the what? Oh yeah, so 6 to 21. So it's like three or four orders of magnitude lower. So I think you'll still need like an ASIC to do this. Maybe not.
Yeah.
But
That's a little disappointing.
Yeah.
Right.
Yeah.
I want to use my Raspberry Pi.
Right?
Yeah, good luck with that. Yeah, I guess you still need some amount of hashing power even on the testnet network, because otherwise I can just, if I'm a troll, I can spin up a testnet node that creates like empty blocks and ruin the next code along session that happens. Yeah.
Right. Okay. So that's what it is. Okay, because I was wondering, like, what is the point of putting in so much work and effort into mining fake coins or testnet coins?
Yeah, it's for development, because you still want stability even for testnet. I mean,
Okay.
for BSV, it's it's the transaction fees are that low that a lot of people just test on the mainnet. You can create like thousands of a transaction for like $1 or so. So that's fine as well if you really want to secure your testing as well. But I use testnet a lot, and it usually works just fine.
Beautiful. Yeah, this is a cool little session. I love it. Got to send out some Satoshis.
Yeah.
Okay, great.
Yeah, really, really cool. Thanks so much. It's awesome.
Yeah, I'm glad you like it.
Yeah, what we're trying to do is try to write or actually inscribe like one-stat ordinals using this library.
Ooh,
So
Oh,
that would be
okay.
fun to do.
yeah.
Yeah, that would be fun. Yeah, maybe you could, while doing this, maybe you could create like a library that does this, because natively, of course, we, in the BSV SDK, we don't have like ordinal primitives, but maybe you could use that under the hood to create a library to make it easier.
Yeah, we might be able to do that. So we used their JavaScript library, but we wanted to
Okay.
write a transaction like raw. I get like to encode it in there without you. Trying to remember what we did. It was a while back, but I think we're able to do it. So after
Okay,
doing this, I
great.
may be able to work tonight. I'm excited. It'd be cool. I have a feeling it might work.
Yeah, cool. Yeah, awesome. Yeah. And by the way, you could also, I'm sure you know this, but yeah, you have the Ordinals wallet, which sometimes makes it easier to debug Ordinals, and it also has Ordinals on the testnet. So yeah.
Oh, I didn't know that on testnet.
Yep.
Yeah. So yeah,
Okay.
but I don't have any. But yeah, yeah. Cool. Yeah. So maybe we could go ahead and maybe create a custom script template. What do you think?
I'm
For
down.
our
I'm
next
game.
step.
Yeah, that'd be great to
Okay.
see.
Sure.
Awesome.
Okay.
Okay.
Yeah. Any questions? Maybe.
So,
before?
you're about to create a custom script template, and we just use the P2PKH, which is built in. Is that what we're saying here?
Yes. So here we use this pay to public key hash, but we want to use like some custom script,
Yeah,
right?
like a pay to puzzle hash or something like that.
Yeah. Let's do our puzzles, for example,
Cool.
because we have
Yeah,
the
yeah.
code ready. Yeah. Yeah. So let's go ahead and do that.
As we're getting into this, can you also just explain what our puzzle is?
Yeah. On our puzzle is it's basically instead of paying to the address, you pay to some random number, which is not part of your private key. So you basically you don't create. You sign with your private key, but you sign some random number instead of signing the transaction itself. And it comes in handy in like many use cases, such as MetaNet nodes and other things like that. But yeah, that's basically what it does. You don't sign the transaction, you sign some number. And this number could be like invoice number or could be anything else, right?
And would the theory be then that a address that could derive that number would be able to spend those Bitcoins? So for example, if that number was related to, like you said, an invoice, then obviously the recipient of the invoice would know what the number was, so then they could receive it without necessarily the funds ever being sent to the receiving address.
Yes, exactly. Yeah, that's basically how you explain it. So you imagine you have a password script, right? And you can only take the funds by using this password, right? But because Bitcoin is a public network, you don't want to disclose this network publicly. You only want to prove that you know the password without revealing it. And that's basically what our puzzle is. It's like a password without disclosing the password, right?
Yes, I
Does
get
that
it.
make sense? Yeah.
Yes.
Yeah.
Yeah.
What people?
There's the concept of geocaching or something like this, where you go to a physical destination and look underneath a rock or something. There may be like a number written underneath that rock, so you would never have that number unless you went to that physical location, but anyone who went to that location could derive the number, and then they could spend the funds.
Yeah, pretty much. Yeah, that's a good explanation. Yeah.
I like it. It's like a treasure hunt.
Yeah. So yeah, you can use it for many different things. You can use it for treasure hunts or other things. Yeah.
Great. Yeah, excited to get started.
But yeah, so let's go here to examples. So you scroll down and you hit examples. So that's the next page on your Python documentation. And hit here script templates. Yeah, so this page will guide you through writing a custom script template, and you have the R puzzle already ready here. And yeah, we won't go over like how exactly it works because it contains like multiple opcodes that would take like maybe a few hours to even go over. But yeah, let's just go ahead and copy this class.
Okay, our puzzle. Okay, I see. You understood. Yeah. So we're gonna create a understood. I got it.
Yeah. And now in here, we're going to use the same file, demo.py, and let's just, under these imports, let's just paste it in here. So, oh yeah, I pasted the wrong thing again. Okay. Yeah, so we have our puzzle in the same file, our custom our puzzle script template.
Let's see here. I'm coming in. I have a couple errors here.
Okay, what are the errors?
Script template is not defined.
Oh, okay. Yeah, good point. Yeah, let's. Yeah, for some reason it doesn't highlight mine. We should give the same error. But yeah, let's import script template for here, where from BSV. Just add the. Let me just put it in a new line and script template here. So we import that, and we also need script, I think. Yeah, so that's the script primitive. And we're also gonna need opcodes. Yeah, I think these are the trees that we need. Opcodes. Yeah. Opcode, yeah, that works. Yeah, I think that's all, hopefully. Yeah. Oh, yeah, private key. We have the private key. Oh, SIG hash, maybe that one. Yeah. So SIG hash. Yeah, I'm not sure why it's not highlighting for me, but
I have another one here.
Yeah, hash. Yeah, what's yours?
Encode push data.
Encode. Oh yeah, that's probably encode push data. Yeah. Yeah. Yeah, since you have syntax highlighting, could you just go over them and read it out aloud so I can put
Sure.
it in here? No.
The other one is optional. It's under the unlock. Yeah.
So that's a type. So you're gonna do from typing import optional. So that's a Python built-in. So because Python is natively untyped, right? But you can use this typing module to, type the parameters, and it's an optional parameter. You don't necessarily have to do this, but this example does have them. But maybe, yeah, this page should probably be extended to include these imports. But yeah, anyway. Yeah.
The other one I have here is a SIG hash is not defined.
Yeah. Yeah, I already added this one.
Oh, did you? Okay, let me add that here.
Yeah.
SIG hash. Okay, that one's done. What else? Hash 256.
Yeah, hash 256. Hash 256. Okay.
Okay. I think this is the last one here. To unlock script template.
Okay, to unlock script template, yeah. Yeah, maybe just put it in another line so it's visible.
There it is.
Yeah.
Okay, I think that is it. Let me just double check here. Save. Yeah, no problems have been detected. Perfect.
Okay, great. Yeah. Yeah, just check that you have the same. Rachel.
Yeah, I'm good.
Okay.
Good.
Yeah, so now we have the script template ready. So again, yeah, we won't have to go through all of these. So it has a constructor which lets you put in the puzzle type, since you can, make it work on raw puzzles or on hashes as well. And the template also defines this lock method, and this produces the locking script. So locking scripts are in the output, right? And this produces a locking script for an R puzzle. This code.
Right.
Yeah. And you also have a corresponding unlock, and this produces the unlock script, but with the caveat that you have to put this in here in a callback function, because this sign function will be called when you call the tx.sign, right? And that's where the actual unlocking script will get constructed. So you have this callback sign. And you also, since you want to know how big the estimate unlocking script will be, you have to define also this callback. And this callback will be called when we call the fee method, right? And because all script, all our puzzle scripts are basically the same size, we just return a fixed number here. But it could be, in your case, in your particular script type, it could be dynamic, so you would probably perform some calculations in here, right?
Mm-hmm.
Yeah. So again, script templates define how you create the locking script and the corresponding unlocking script. That's basically it.
And
Yeah.
so, like in the case of some kind of a puzzle, one's answer to the puzzle would basically provide the correct parameter, or there's probably a better word, that would be contained within that unlocking script along with their signature. Is that correct? Is that a way to say it?
Yes, it is. Well, in our puzzle's particular case, it actually includes a signature, but this signature isn't a regular Bitcoin signature, but it's also a signature that proves the knowledge of some number or string or some message, right?
Okay.
Yeah, but essentially, yes, the unlocking script contains all the proofs that you know the solution to the puzzle. It's the solution to the puzzle, which is a proof, right? Yeah. Okay. So now in here, let's just, because we created another transaction, right? So this was already spent. So let's go to our browser, and we have this new transaction, right? So let me find it. So that's our latest one, right? Where we paid 30,000 to ourselves and 60,000 back as change, right? And we're gonna reuse this transaction to take these funds to pay for our puzzle. Okay.
Sounds good.
Yeah. So again, we're gonna copy the transaction ID here, and then we're gonna go to. I think I closed the. Yeah, let me just find. Then we're gonna create a link again, right, to get the raw transaction. So let me go back to the text editor. And change this to test again and put in the transaction ID here. Like that. Okay. I have this link. right? Following along?
Yeah.
Yeah.
Okay.
Yes.
And put it in the browser again. And we're gonna have a download. So let's open it. And here's our transaction. So let's just copy that again and put it in here. Like that. I think that should be it. So yeah, let me just double check. So 175. I think that's it. Yeah, 175. Okay. Okay, let me know when you're done.
Yep. Raw data extracted.
Yeah,
Cool.
good.
Great. Yeah, so in here, yeah, so the input. Oh, yeah, I'm not sure what that sound was, if that was coming from my computer.
Oh,
But
no, that was
yeah.
me. Sorry.
Oh, okay.
That was
Yeah,
my
no problem.
Alexa there being nosy.
No problem, no problem. I thought that we might lost connection or something, so I'm just checking.
Oh, okay. I'm sorry. I meant to call Alexa nosy, not nobody here. I'm sorry. I don't know if that came up.
Yeah. Yeah, sure. Yeah. For some reason in my car, because I have Android Auto, Google always thinks that I'm talking to them, so it always opens up the assistant. Yeah, similar things happening. Yeah, so in here, yeah, because this is also in this transaction, this is also a pay to public key hash. So we're gonna use for the unlocking of this source transaction, we're still gonna use the pay to public key hash template, right? So, and we're gonna unlock the first output, which contains 30,000 satoshis. And okay, so yeah, that's for the input, stays the same. And for the output, we don't want to pay again to a public key hash, but we're gonna pay to an R puzzle, right? So we're gonna just comment out this line, and we're gonna put in a new one, and put this in, change this to an R puzzle, and let's see if it takes in any constructor arguments. Yeah, it has a default one, which is a raw. So just leave it empty. And so let's take a look at what the lock function takes in. It takes in a value. So that's the R value. So I think this should work like with any regular value. And I'm not sure if it needs to be a specific size. Maybe there's some check in here. So value encode push data. Yeah, I think it should be, could be anything. So let's just, yeah, maybe it would be best to hash it if it's not something specific. So maybe put in here that it should calculate hash 256. I think it's supported. Yeah, sorry if I'm jumping around too much, but I don't remember the interface by head. So yeah, hash 256.
It's helpful to see this process.
Okay, cool. Yeah, so it's hash 256 with capital letters. So let me correct that. Hash 256. So yeah, that's in the rpuzzle constructor. So right, rpuzzle hash 256, and then we call the lock method, and we put delete this from here, and let's just put in some random bytes value. So we can use bytes from hex. It's built into Python itself, and we can just put in like a random hex string. So AA, FF, 11. Could be anything.
Yeah, when you're done doing that, I'd like to go over that one more time. Just make sure I'm doing everything right.
Okay. Yeah. So where are you stuck?
So you were changing a couple variables around. I see here hash 256, for example. You had to capitalize it, I guess. Is that what you did?
Yes, yes. Yes,
Um,
I didn't change anything above, so you just wanna make sure that this line is the same as yours.
okay, let me. R puzzle. I'm doing a control F to see. I might have gotten a little lost here. Locking transaction output. Bear with me. Uh-oh.
Okay, sure. Just take your time.
Okay.
So that hash 256 is double hashing with SHA 256, right?
Yeah, yeah. So this is basically the R value, right? So instead of just putting in the R value as it is, if you choose a puzzle type in here and put hash 256, it will hash this value before and put in the hash value.
Okay.
Yeah.
Get raw transaction. Where am I? Oh boy. Here I am. Okay. Okay. So just to make sure, yeah, the example script templates is what we copied, but for whatever reason, I'm not seeing. Locking string. Sorry guys, give me 1 second. Okay. Oops. Locking script, and then you did that. Okay, so in the output, locking script equals R puzzle.
Yep.
Yeah, this is for whatever reason it's not showing up for me. Did I copy the thing? Let me see here. Is that a new function that you're calling transaction? Is that a new in line 103? Is that new? Is that something that you did manually at some point?
This transaction output.
Yeah, or was that just a copy paste that you did from the example, the script template?
No, this was already in here. This is what we used in our previous example. So I'm just changing this demo.py file, and this was already in here. So I commented out this locking script that was paying for a public pay to public key hash, and instead I put in the R puzzle. So we could just as well delete this, right?
Okay.
Yeah.
Okay, so I just need to then change that part here. Locking. Maybe just do it easier if I copy paste here and then just make the necessary changes. So you did R puzzle hash 256. Do you mind just to save some time, would you mind just copy pasting it on the chat over here, so just to save everybody's time too, so we don't have to wait up
This?
on me. Yeah, please.
Okay.
Yeah, that helps.
Okay. So in here. Oh,
There
this
you
is
go.
wrong
Oops.
again. Yeah, no, I'm not sure why I didn't copy it. Yeah. Why doesn't it copy? Maybe try with mouse. Copy. Okay. Now this.
Okay, thank you.
Thank you.
Yep.
All right. Should be back to me.
Okay. Can we continue then?
Yes. Yes. Thank you.
Okay, great. Yeah, no problem. Yeah, so also let's change the Satoshi amount here because it's 30,000, but we're already unlocking just 30,000, so make it something less. Let's make it, I don't know, like 10,000. Okay. And let's leave the change output the same. Okay.
Because the change output is just going to calculate based on the fee rate. So you don't have to change that because it's basically the same format as you would use with a paid public key hash. Is that correct?
Yes, exactly, yes. And you want the change to be just a regular payment. You don't need it to be on our puzzle since it goes back to you again. Anyway,
Okay.
Right, into your wallet. Yes. And yeah, that's basically it. But here, if you notice, we're only creating an output with an OR puzzle. But I guess we also want to unlock it, right? So we had to create another transaction. Yeah, hopefully this will all work on the first go. So in here, when we finish broadcasting and creating the first transaction, let's create another one. So let's call this TX2, right? And let's do transaction. And we're gonna, yeah, let me just copy this in here. And in here, we're gonna unlock, sorry, we have to first create the inputs of this new transaction. Yeah, so let's just copy these, all the inputs and the outputs, and we'll change them on the fly, just to be a bit quicker. So let's rename them. Let's make this TX2 input. And the source transaction will be our first transaction, so TX, right? Because we're unlocking it. Right? And we're also going to change the unlocking script template because this output that we're unlocking with this input will unlock our puzzle. So let's just copy this. Yeah, where are we? Okay, yeah, sorry. And paste it in here, and we're gonna do unlock here, and let's see how we do it with the, yeah, and what it takes in is the K value. Oh, yeah. I just realized I forgot a bunch of things that we also have to do in order to unlock our puzzle. And I'm not sure we have the appropriate amount of time left to do it. So
Could you?
I'm gonna, yeah.
Oh, I was just
sorry.
going to say, could you just say big picture what that means?
Yes, big picture. Yeah. So instead of using the pay to public key hash that we used earlier, right, to create a transaction, to lock our new transaction in, we use a custom script template. So instead of using a pay to public key hash locking script, we create an R puzzle locking script. And this R puzzle has some custom characteristics, a custom script, and also the unlocking script is different from a regular paid public key hash. And the goal of this exercise was to show you that you can define custom script templates. So it doesn't have to be an R puzzle. You could maybe define, like, I don't know, like some custom, I don't know, depending on your service, something that you might want to use. It doesn't have to be our puzzle. It could very well be an script contract or something like that, right? Which has each contract has a unique locking script. So that's sort of the high level goal that I was trying to show you. But yeah, I forgot a couple of things since I'm improvising. But what I could maybe do, and I guess you don't have to follow along, is if I go to the Python SDK into this repository, you have so this is the repository of the SDK, right? So this is all the code, it's open source. And you have this little examples folder in here, right? And in here, you have the OR puzzle. And this is basically what we were trying to achieve, but it's all already done. And as you can see, it has a bunch of like additional stuff in here, which is to actually get the K value and the R value that's derived from it.
Right.
And instead of trying to do this now, since we don't have a lot of time left, let's just maybe try to copy this. And you don't have to do this. I'll just quickly do it so we can try if it even works. So let me maybe create another file.
So just to ask a layman question, the R value and the K values, are these related to curves?
ECDSA, right?
Yes, exactly. Yes, that's an ECDSA. So the R value is basically a derivative of the K value. The K value is the private part, and the R value is the public part. So you can verify that any verification algorithm can verify that K really by just seeing R, it sees that it was actually made by the valid K. Make sense?
Yes, and this could be valuable in the sense that you're allowing for specialization of functions where maybe the revealing of the data could give away some proprietary knowledge that maybe a solutions team has figured out on their own, such as, for example, some unique number relating to pi, the nth digit of pi or something like this, and they're having that knowledge proprietary is valuable to them, so they don't want to expose it, but they also want to prove that they have that information, and they can do that by using an R puzzle and deriving the value R from K. Is that correct?
Yes, essentially, it could as well be used in computational puzzles, but for computation specifically, since you mentioned, the nth digit of pi or whatever, it's usually best to verify that in the script as well on chain, right? And you do that by using snorks. So I wouldn't use R puzzles to do that particularly, but on a higher level, you're right. Yes, it's essentially just proving that you know some specific chunk of data. Yes.
Mm-hmm. Okay, thank you.
Yeah. But you don't necessarily, with an R puzzle specifically, you don't necessarily validate the structure of that data. So you don't check that it's actually really the nth digit of pi. You just check that it's some secret value.
I got you. Yeah, that makes sense.
Yeah.
So,
Yeah.
Thank you.
Okay. Yeah. So Jim, let me just quickly go ahead and change in the script that I just copied. Let me change the private key and transaction.
Just really quickly, I want to maybe throw out another use case. Maybe another use case could be, for example, individual's private health files or something like this. It would be important to know that a prescriber may have access to those health files by validating some derivation of the hash of those health files, while also not necessarily revealing the health files on the public chain, because of course that would expose private information about a person. So this is a nice way to ensure that information has been validated and verified without necessarily exposing what that information is.
Yes, exactly. That's a really good use case. Yeah. I'm glad you brought that up. Yeah. So I think I have everything ready now. So let me just try. Hopefully it will work. And
Fingers crossed.
Fingers crossed, yes. Let me just, yeah, it's testnet, okay. Testnet, right, okay. If not, no problem, but yeah, let's just try. Okay, it says it has, but just to verify, sometimes it's lying. Okay, yeah. Yeah, so this one, so see, it's a non-standard script. So Watson chain doesn't natively, read that it's actually an R puzzle, but this output has an R puzzle locking script, right? So it's not the usual op hash op equal verify objects, but it has some additional stuff in here, right? And it actually also successfully unlocked it, and we transferred the funds back to our wallet, right? So it succeeded.
Nice.
Yeah.
Beautiful.
Okay. Yeah. Yes. Yeah. Again, these examples are also in here in the Python SDK repository. So in the examples folder, you have also many others, such as for encryption, key derivation using ORC, broadcaster, and stuff like that. Yeah. Okay.
Interesting.
Yeah.
Nice.
Yeah, I think it's a good point to maybe wrap up. So, any questions maybe so far?
No, not from my side. I just I'd have to take a look at the libraries there, and yeah, it looks really interesting, especially this last part that you were talking about. I think just recently the BSV Academy came out with the opcode course, because you had mentioned that it would take a long time to actually explain what that is, and that's something that I've been looking forward to learning about very soon. But yeah, I just thank you for.
Yeah.
Okay, cool, awesome. Yeah, definitely learn about that, because it will give you the required knowledge to create something like this, for example, right? A custom script template, because here you sort of have to know what it does to write something like this with all the individual opcodes.
The script course in there, and I don't know if how much longer BSV Academy is going to have that course online. Maybe you know, Brett. I know they said, Todd said recently that it's going to be sunsetted in a few months, but the script course has all this stuff. It goes through the R puzzle, everything.
That's good to know.
Yeah. Yeah, it's good to run through, Rachel, if you haven't. It gives you a really, I felt a solid foundation. It's not
Yeah.
like fast to run through it, but it's good.
That's the Bitcoin script one. You can see I have a bunch of notes from it. I'll have to go through that again.
Yeah, really helpful. And especially I like where you brought it to at the end with the example of the R puzzle and the custom script and the custom unlocking capabilities, because one of the things that I'm really feeling about the emergence of blockchain as a solution provider is the way in which it provides a beautiful marriage between the public and the private components. Of course, you get a lot of advantages by having a public element to data that you're working on, because potentially there could be solution providers out there that have the ability to fill in key functions that that maybe are outside of your specialization. And but of course it's always important to have a firewall between the data that you need to leverage uh, from a public capability standpoint, but also retaining the privacy of the individual user. And so I think that this really represents that perfect marriage between those two. And seeing that you spent so much time to really build that in from the ground level, Michal, it's really exemplary. So I want to thank you so much for that.
Okay, thank you. Thank you, Red.
Do we have time for one more like high level question?
Absolutely.
Okay, so and Rachel, this could maybe answer this too, because I know you've worked a lot in this, but why would somebody choose the Python environment over perhaps the TypeScript / JavaScript environment?
Well, one thing is familiarity. So if you started out learning with Python, for example, which a lot of especially new developers do, it's easier for you to do it. And the second part is also integration with existing tools. So for example, if you have all your infrastructure written in Python, it's not really the easiest to make it interface with JavaScript. It's much more convenient if you already have the SDK in Python.
Beautiful. That's perfect. That's the exact answer. That helps.
Okay.
Yeah.
Yeah, let me maybe stop my screen share.
Sure. And then do we have any other questions before we conclude things?
No.
I don't think so. Thanks for doing this.
Yeah, thank you so much. Wow, super helpful.
Okay, glad you liked it. Yes.
Yeah. Well, thank you very much, Michal, and thank you, Jay, Bridget, and Rachel for joining us. These have always been, my favorite sessions to run. We're looking to maybe do another one of these, maybe, a few months, maybe 3 months or 6 months down the line or something, another revisit of, Python code along, maybe getting into a little bit more, complex features and things that aren't built in to the SDK out of the box, but allow that extensibility, like you said, maybe showing some of the integration with Scrypt. But until then, thank you very much for joining us today, for being along on this journey. For your BSV Skills Center, we showcase the Python library brought to us by Michal. He is a key developer and senior lead at Scrypt, which is a domain-specific language of TypeScript, allowing innate Web3 blockchain functionality, smart contracting, and as we just saw, customization of locking and unlocking scripts, all from the basic frameworks that we're familiar with, whether that be, as we just showcased, Python or with a TypeScript framework. So please explore our BSV Skills Center. As Bridget mentioned, take some time to check out those scripting classes as well on the BSV Academy. And thank you so much for tuning in. This has been a code along session for the BSV blockchain with our Python library. And we're looking forward to bringing you more exclusive content to aid you in your developer journey. My name is Manifestable. And in addition to hosting these spaces, I'm also here to help bring your project to light. So something that you're working on, whether that be the project that Bridget mentioned in the beginning, showing her skills as a full stack developer and showing some of the scripting capabilities of BSV, or as Rachel discussed, her project with Gibio, allowing users to upload content in the form of podcasts and be able to be paid on a per user, per listen basis. Or as we saw with Jay, the ability for NFT functionality and simplified payments for whether it's gaming or other Web3 components by using the Handcash SDK. There's lots of ways that we can help support your project here in the BSV ecosystem. And I'm a great resource for you to be able to achieve that. So reach out to me at brett.banfi@bsvblockchain.org or at my Twitter handle, Manifestable. Until then, thank you so much for being a part of this demo, and we'll see you on the next one. Have a great day.